Hey folks, thanks for joining us today. I'm going to give everyone a second to log in and then we'll get started. All right. Hello, everyone. Good morning, good afternoon, wherever you're joining us from today. Welcome to today's webinar, co-hosted by the New York Oracle User Group and Oracle partner, Viscosity North America. We've got a great presenter with us today, one of my awesome colleagues. So I'm super excited to have him presenting for you all today. This is a live webinar, so feel free to submit questions in the Q&A field. And James Vanderpoel, who's presenting for us today, will get back to you as he can or following today's webinar. Any questions that we can't get to today, we'll be happy to try to reach out to you afterwards with any information that we may have for you. All right. So if you're not familiar with us, welcome. Glad you found us. New York Oracle User Group is going to talk a little bit about themselves. Viscosity will do a little pitch as well, and then we'll get started for the day. It is a recorded webinar, and yes, you will get access to the recording as well as any other material such as slide decks that the speaker decides to share with us. So with that, I'm going to hand it over to Coleman from NYOUG, and he's going to tell us a little bit about their group.
Thank you, Monica, for the kind introduction. So, New York Oracle Users Group was formed in 1984 for the exchange of ideas, assistance, and support among users of Oracle software products. Next slide, please. And you can connect with us on X, on Meetup, LinkedIn, Facebook, and our webpage is nyoug.org. You can see a list of the webinars that's been occurring since 2020 at that link at the bottom. And if you have any questions, just email myself. You can find me at the website, and we can provide those answers for you. Just a little summary. The next webinar is coming up is July 26th, this Friday. It's going to be an Exadata AI webinar. Then we have one coming up on July 30th, which is Apex, and they're going to be a discussion with AI and Apex. Next one is August 6th. It'll be AI and machine language from Oracle. And then finally, the next one is going to be Sean Stacy's going to talk about 23 AI with the AI vector. And we've just got okay for another one by Mark Suits. He'll be talking about Apex and AI, and that's going to be August 20th. So we've got a ton of webinars lined up for this summer. And all you have to do is look on our website or look on Viscosity's website. You'll see the list of events going on. Thank you, Monica.
Thank you so much, Coleman. We hope you guys register for some of those events coming up. And we will remind you guys too as you get our emails. All right, my name is Monica Lee. I'm the marketing director here at Viscosity. We are a full Oracle Stat consulting firm with core expertise in Oracle database that includes RAC, Oracle Apex, near zero to zero downtime migrations. I do a lot of performance tuning and high availability projects for our customers. And we do have decades of experience with infrastructure, including engineered systems. So I'm super excited about this Friday's Exadata AI presentation. All right, so real quick, these are the three pillars that Viscosity is built upon: data, apps, and cloud. If anything on this screen resonates with you, please give me a shout out. I'd love to see what we can do for you. Everything across the bottom obviously kind of falls in suit with the three different pillars. So workshops, assessments, training, managed services, you name it. While we are a full Oracle stat consulting firm, James here, this is a great a great showing of our breadth of skills and knowledge. So we do cross over into SQL Server and Postgres as well. So we're glad to have you guys here. I know this is an Oracle community, Oracle user group. So we're excited to see what you guys are doing, maybe outside of Oracle as well. On this slide, I just highlight some of our most popular books. We do have, I think, over 25 books with our consultants. Our newest ones would be Oracle Database Performance Tuning, Upgrading Oracle Databases, Oracle on Docker came out within the last year. And I think that's it. So these two right here, they do get renewed or re-updated around Oracle Cloud World. So that should be coming up soon. Okay, and on this slide, I just like to highlight some of our recognizable faces at Viscosity. If you've seen any of these wonderful Oracle ACEs and Oracle ACE alumni throughout webinars, conferences, etc., go say hi to them. They've got great content online, blogs, their tweets, their actual publications. So great amount of knowledge. We love knowledge share here at Viscosity. And if you're not familiar with the Oracle ACE program, check it out. Coleman here is one of the Oracle ACEs for what he does for the Oracle community and things like this with NYOUG. So there's tons of different types of Oracle ACEs out there. We're very proud to have 5 of them and 1 Oracle ACE alumni. Okay, and then after this webinar, we'll be posting the recording and any slide decks or anything else to orapub.com. This is actually where Viscosity puts all of their training material, so you can see years worth of webinars, slide decks, even slide decks from just conferences. So maybe there's no recording, but you can find everything there. We do live training as well. We've got great tools within Orapub. Definitely check it out. You can become a free member or you can get extra perks with a paid tier. I always recommend people to ask their employers for reimbursement if they do, because it's great continued education here at Orapub. Okay, and with that, I do want to remind everyone that you can actually get NYOUG and Viscosity webinars on nyoug.org as well as orapub.com. So check that out. And otherwise, sign up for our upcoming events in person and webinars like this. And I think with that, I'm going to hand it back over to Coleman to kick us off.
Thank you, Monica, for that kind introduction again. And I just want to say that we've been doing this since 2020, and we've got many more months and years ahead of us in doing these webinars. So they'll continue. I want to introduce James Vanderpoel, who is a member of the Viscosity team, and he's going to take off this webinar today. Thank you again, James and Monica.
All right, thank you, Coleman. I'm going to go ahead and share my screen, if that's okay. Okay, let me know when you can see it. Should show the Viscosity Professional Services. Excellent. Okay. Nice to meet you all. My name is James Vanderpoel. I'm a senior principal consultant here at Viscosity North America. Excited to be presenting today this topic of Postgres SQL table partitioning. Here in the lower right corner, you'll see my LinkedIn profile, email if you want to email me a question, as well as a Twitter handle for Viscosity. Just a quick summary of me or of what I've been doing. I'm a senior principal consultant here for Viscosity. I've been such since August of 2023. I specialize in Postgres SQL as well as SQL Server, all things Azure Cloud, and anything really data related within the Microsoft ecosystem. Prior to my role here at Viscosity, I served as a senior database administrator on a variety of production and development operations teams for a number of companies and industries ranging from finance, banking, and energy. I've done so for, I think, nearly a decade or close to it. It's crazy to realize how old I'm getting, but that's just a quick summary of me. I'll go ahead and cover our agenda very quickly. We're going to start with, what is table partitioning? Why would you be interested in using such? The types of partitioning available in Postgres SQL. Spoiler alert, that'll be partitioning using inheritance and something called declarative partitioning, which we'll get to. And of course, we'll follow up with key concepts and best practices, and then we'll have 2 demos there at the latter end. So if everyone's cool, I'm gonna go ahead and get started. What is table partitioning and why would you use such? So partitioning is a technique that allows us to split large tables into smaller tables in a way that's completely transparent to the client application. Why would you use such? It's going to, and under the right circumstances, help to improve query performance and data management for large data sets. Basically, improve query performance. Partitioning enables faster query execution times through something called partition pruning. In SQL Server, we sometimes refer to that as partition elimination. Reducing the amount of data to be scanned. We'll cover more partition pruning in a later slide. Additionally, it allows for just generally across the board easier data management. Partitioning simplifies the management of large data sets by splitting them into managed partitions, streamlining actions such as archiving, purging, and backup and restore operations. Your main use cases for such are going to be large data sets, tables of large size with varying query patterns, any requirements you might have for the archiving and purging, and of course, performance optimization for specific queries and workloads. Partitioning enables something called parallel data loading and more efficient indexing, leading to faster data ingestion and improved query performance. It can afford users the ability to choose for less frequently accessed data to be stored on cheaper storage medium, while keeping more frequently accessed data on faster devices by mapping database objects to things called table spaces. We will cover that in a later slide. Smaller partition tables and indexes can lead to higher cache hit ratios and reduced I/O. Basically, smaller indexes on partition tables can be kept in memory for longer. We used to call this page life expectancy, I think, in the Microsoft world, but in Postgres SQL, you can just think of it as that. It helps plan to faster vacuum processes by allowing the vacuum process to do piecemeal partitions, and it reduces disk space usage during full vacuum operations. Vacuum full operations basically take the size of the table and effectively double it generally within memory. So if those indexes on the partitions are smaller, it can help alleviate that effect and keep more memory available for current operations. So we're going to go ahead and go through types of partitioning supported in Postgres SQL. There's something called partition using inheritance and declarative partitioning. We'll cover declarative partitioning first. That was first introduced in the Postgres SQL 10. That is declarative partitioning. It is the recommended method. Partitioning tables is what you think of when you think of quintessential partitioning. It supports 3 different partitioning types: range, list, and hash. Range partitions are where you partition into ranges defined by a key column with both lower and upper boundaries. That's common for use cases like dates, as well as just maybe business ID objects. There's something called list partitioning. That's where you explicitly list partitioning key values in each partition, and that's where those values will fall into various buckets. And then there's something called hash partitioning, which is where you partition by specifying a modulus and a remainder for each partition. The partition will hold the rows for which the hash value of the partition key divided by the specified modulus will produce the specified remainder, and that will determine which partition a row falls into. Then there's something called partitioning using table inheritance. That's the legacy method available to Postgres SQL releases prior to version 10. This method uses constraint for defined partitions and user-defined rules or triggers to route data to the appropriate partition. The key characteristics of this are that child tables can have additional columns not present in the parent table, and it also offers flexible partitioning beyond range, list, and hash options. I will note that this method is no longer recommended and is superseded by declarative partitioning, again, with Postgres partition release 10 and beyond. We will cover partitioning using inheritance just for the sake of completeness. Few jokes. What's the object-oriented way of getting rich? Inheritance. Postgres SQL applies object-oriented inheritance to database tables. Here's how. You'll basically define a parent table. In this case, we use an example of table 1 and child tables, table 2. The child table inherits everything from the parent table, and then all records in the child table are automatically accessible through the parent table. You can see some DDL. Give an example of this. Here's a create table. Here's the 2 child tables that I would create. In addition to that, you actually have to define the triggers of functions or rules in certain cases that would allow the routing of rows. So in this case, you see here's the DDL for altering a table and adding a constraint between 1 and 100. And in this case, we have a second child table with a constraint for values of the employee ID between 101 and 200. Got a function here that will basically effectively route those rows and a trigger, which I then attach the function through the trigger to the parent table. You'll notice here I basically insert into this employee's parent table. And you'll notice here, this is just a quick example of where the data would fall. If you select from the parent table, you'll get the results of both. But if you select from each child table, you'll see where those values landed based on the constraints and triggers that I've set up. So we'll go ahead and enter into declarative partitioning. If nobody has any questions with inheritance. This is introduced in version 10, and it's been enhanced in subsequent versions, offering improved ease of use, performance, and features. This is the preferred method, as I said previously. There are some concepts here to cover. There's a partition table. This table is to be divided. It's basically virtual. You can think of it almost as like a view in storage lists. There's a partition method, which I discussed earlier, when we'll go into more detail of each of these. There's hash, range, and list partitioning methods. And there's a partition key, or the key candidate column, which is a column or columns or expressions to determine what to partition on. Oops, sorry about that, a little too far ahead. How it works. Partition table is considered a virtual table having no storage of its own. The underlying partitions are the actual tables where table storage is mapped to, and that's what stores the data. Rows are routed to the correct partition based on the partition key. And the updating of a partition key may migrate a row to a different partition if it no longer meets the original partition's boundaries preset. This is something to keep in mind. There are advanced partitioning features to go along with declarative partitioning. There's something called sub-partitioning for enhanced partition pruning. Basically, this is where you take the partitions themselves and turn them into partition tables, and they themselves would have essentially sub-partitions. And that can have increased potential gains in specific use cases. There's partition flexibility. Partitions can have unique indexes amongst them. So all the partitions within a partition table don't have to have the same indexing strategy. You can mix and match to your heart's content, along with constraints and default values. And that can lead to more efficient indexing choices. Partitions can also be foreign tables, but user care is recommended because the actual partition rule compliance is going to have to be defined and created outside of Postgres. Let's go in that case. Partition table management. Partition tables are virtual, cannot be converted to and from regular tables. That's because, again, they have no storage themselves. The underlying partitions are such. And you would use the attach and detach partitions to add or remove partitions, converting them to standalone tables and vice versa. This is just a note. Table constraints, partition boundaries, and declarative partitioning are implicitly defined. You don't have to manually create them yourselves, but you can do so in conjunction with certain partition management strategies, and we will cover that in a later slide. This is just an example real quick of declarative partitioning data definition language. You'll see here, this is the actual creation of the partition table. You specify in that point the partition method, which could of course be range, list, or hash. And then over here on the right, I have DL examples of the various partition methods you use: range, lists, and hash. One note is that for values, clause changes based upon the partition method you use. For range, you have from, lower, and upper bounds. For list, it uses an in clause, the same way you would an aware clause. And then for hash partitions, you of course define a modulus and a remainder integer value. We'll go ahead and go over range table partitioning first. On the right here are some examples set up for you. Incredibly simple. I just wanted to make them easy to digest. In a range partitioning, you organize rows into ranges based on a key column or columns with boundaries specified. The lower bound, it's important to note, is always inclusive, and the upper bound is exclusive. I point that out because you'll see here that the boundaries of two partitions will have overlapping values, and that is because the upper boundary is exclusive, whereas the lower boundary is inclusive. Partitioning by date or identifier ranges are examples. I have two here. In this case, I'm partitioning on an integer value, and on this case, I'm using a timestamp. Even though I don't mention the actual time, I'm using the date. Here's an example of insertion behavior with those upper and lower boundaries, exclusion and inclusion concepts. You'll notice here, if I were going to use this one right here and insert a value of employee ID 6, that would actually fall into the employee 6 through 10 partition. because the upper boundary is exclusive, and so therefore you would find that that value would land here. Next, we're going to cover lists table partitions. I don't see any questions yet. If you have any, don't forget to ask. When list partitioning, rows are divided partitions based on specific values in a column. This partitioning scheme is useful when data can be categorized in distinct, non-overlapping sets, and those values are predictable and stable. You probably wouldn't want to use list table partitioning if you have a lot of incoming new values for that partition key candidate. Reasons are, I think, self-evident. Here's an example here of a table of products where we're partitioning by the category: sports gear, electronics, tools, things of that nature. So that is list partitioning. And then finally, we have hash table partitioning. So this, you distribute rows based on hash values, which are produced after you specify a modulus or divisor and a remainder for partition. Here are some examples here. You'll notice I'm partitioning on customer ID or customer name. I'm showing in this case that you can, regardless of the fact that you're using a modulus and a remainder, you can use character or variable character data types. Rows are assigned to partitions based on the hash value of partition key divided by the modulus, producing a specified remainder. Ideal use cases for this are when there's no natural, partitioning method existing, and hash partitioning will ultimately evenly distribute the data, provided, of course, you don't have a lot of null values, which I note here always end up in the partition with a remainder of 0. So that's something to keep in mind, the amount of nulls available, the cardinality of that. Partition maintenance, adding new partitions is pretty simple. It's just like when we initially created some partitions. You create a new partition based on timestamp column in this case, using the create table partition of syntax. Partition maintenance, adding new partitions, alternative methodology. So this is something to note. To minimize blocking conflicts, a lot of times it's recommended to create a new table outside of partition structure that you intend to be a partition, and then attach it as a partition later using the attach partition command. Some key benefits to doing so are that when you do it this way, it only requires a share update exclusive lock. That's viewed as less restrictive to current operations than an access exclusive lock, which is always required when you're adding a partition to the partition table. Some optimization tips. I have an example down here below of order partitions here. You basically, it's recommended that you create a check constraint before adding said partition. That would basically duplicate the implicit logic of that constraint when you add a partition. And this is going to help you avoid a scan that would otherwise be needed to validate the implicit partition constraint. And then you can basically recommend that you drop the check constraint after you add that partition to the partition table. To remove an existing partition from partition table, use the opposite attach partition command. This is basically a metadata switch. It's like doing a rename. You're not actually having to move the data itself. You're just repointing. So it becomes necessary sometimes to maintain relevant data onto my storage and periodically remove partitions containing outdated data, as well as adding new partitions for incoming data. Modifying the partition structure to quickly eliminate large data sets avoids physically moving data and reduces execution and hassle. And of course, once you move a partition out of a partition table, you're of course free to truncate it, which is a DDL command, and it's much faster than, say, a delete. So dropping partition table, detaching, and dropping partition table allows you to eliminate millions of records quickly from the partition table. You avoid the access exclusive lock on the parent table, and helps you, of course, outperform the partition delete operations. Handling unpartitioned records. So there is this concept of a default partition, and it serves as a catch-all for all records that exist outside of partition boundaries. If you don't have a default partition defined already, any records that come in that would fall outside the scope of partition boundaries defined would cause that insert to fail. So it's a good idea to go ahead and have, this is the kind of an example of failure that would occur if you didn't have that default partition defined. And here is an example of how you would define a default partition. To avoid this, it's recommended to create this default partition where all values that are reflected in the mapping of the child tables will be inserted. And then after the fact, you can migrate those rows as needed to a proper partition as you define it. Partitions and table space. So table spaces basically map in Postgres SQL database objects like tables to file paths and files. You associate table spaces with tables And since a partition is itself a freestanding table, you can map various partitions to different table spaces, and therefore afford yourself the ability to associate, more frequent access data with, say, faster storage mediums and less frequently accessed data to slower storage mediums. What you'll see here is an example of doing such. Let's move on. Partition pruning. Partition pruning, we talked about this earlier, is a performance optimization technique available to declarative partition tables. With such enabled and under the right circumstances, such as when the partition key column is used in a where clause or potentially a join as well, the Postgres SQL planner may examine the definition of each partition and prove out certain partitions that don't need to be scanned because they couldn't possibly contain any rows meeting that query's where clause due to the implicit current constraints put on them. So in this case, I'm just doing a quick, select from something where a trans date, you can assume that that trans date would be what we're partitioning on. And this is just a visual showing you it's scanning a simple partition and not scanning the other two partitions. So that is partition pruning. Here I have a quick example of such. This is just the DDL to create that transactions table. And you'll notice just real quick, I actually set the partition pruning to off here to show you it's scanning everything. And then I set it to on, just to give you an example, using the explain select to show you that it's just scanning the slug partition, because that's the only partition on which that value would exist. We'll go through a demo showing partition pruning here in a second. It is important to note partition pruning is driven only by the implicit constraints created by the partitions, not by the presence of additional indexes. It is not necessary to define indexes onto key columns. Whether an index should be created partition depends on whether you expect that queries that scan the partition will scan a large part or just a small part, in which case an index would help. Additionally, partition pruning can take place both during the planning and execution phase of the query's life, such as during subquery execution or with the use of execution time parameters like parameterized nested loop joins. Oh, I see I have some questions here. Sorry. For range partitioning, the value falls outside values for defined partitions. What partition is that value stored? I don't know when that first question got, but basically to answer your question, if you have a default partition, that is where that value would fall if you don't have additional partitions with those scopes defined. If you didn't have a default partition and that row fell outside of the scope of partitions defined, that insert would actually fail. Partition-wise joins. Yeah, so partition-wise joining is basically when you do a join between two tables in Postgres, and you basically it does joins between those partitions. It's only available past, I think it was 13 and on. I may actually follow up with that question here after the fact. If you can send that to me in an email, my contact information, with additional information regarding partition-wise joins, and can use triggers on the partition table to have each partition. Yes, you can. A partition is basically just an underlying table for all intents and purposes. And I believe that triggers can be attached or associated with partitions. I will follow up with you more so on that information. Also, if you want to send me an email with that question, or to Monica here after the fact. Okay. Additionally, partition pruning. Oh, yeah, so we discussed that already. So moving on. Okay, sub-partitioning. So real quick, we touched on this slightly earlier. PostgreSQL supports sub-partitioning, where you can further divide partitions that are expected to become larger than other partitions, or otherwise. This can lead to an excessive number of partitions, though. So restraint is advising. Remember that every partition you create is basically, when you're doing queries against it, you're basically doing joins to rebuild the result set amongst the partitions. So in this example, we sub-partition down to days of the month. But you can choose to partition on different columns and using the partition methods, as well as different columns. So you can sub-partition on the same column. Let's say if you want to drill down, like for example, in a timestamp column, you can go from month to days of the week, or from quarters to months. Or you can choose to partition using an entirely different partition method on a different column. In this case, there are implications for that as far as what the Postgres SQL planner will do. So it's important to try to to test out what you're doing if you so choose to sub-partition. Table partitioning and logical replication, we'll just touch on this real quick. Before Postgres SQL release 13, logical replication of declared partition tables was not supported. you effectively had to replicate just the partitions themselves. So basically, you would have to create separate applications for each underlying child partition. But with Postgres SQL 13 release and beyond, partition table can actually be published explicitly, causing all its partitions to be published automatically. Addition and removal of partition cause them to likewise to be added or removed from the publication. And additionally, on the subscriber side, logical replication supporting replicating into partition tables is now supported. It wasn't previously prior to the 13 release. Prior to that, subscribers only could receive rows into non-partition tables. Best practices with partitioning. So it's important to note that partitioning isn't a magic bullet. If it isn't done right with proper access pattern awareness, it can actually hurt overall performance. We talked about this. Basically, every partition you create, when you're doing selects against it, you're ultimately doing almost like joins amongst the different tables. So one of the most critical design decisions you make is what to partition on. The best choice is really going to be a column or set of columns that you most frequently use in where clauses, taking advantage of the partition pruning that we talked about earlier. Also, choosing the target number of partitions is a critical decision. Not having enough partitions may mean, may lead to poor performance not having enough partitions may mean that indexes remain too large and that data locality remains poor, which can result in lower cache hit ratios in memory. However, having too many partitions can also lead to longer querying planning times and higher memory consumption, both during planning and execution phases. There is more reading info, where to go from here, that I have available here. This is official Postgres SQL documentation. This is just the wiki they have for DDO table declarative partitioning, as well as something called PG Partman, which is an extension for the creation and maintenance of table partitions. It's really good stuff. It's GitHub location here where you can go look at that. Just remember that all Viscosity hosted webinar recordings and conference sessions and slide decks we've posted to orapub.com for free and paid members shortly hereafter. And then we have the end basically. Remember to keep up to speed with all our upcoming events. And we do have 2 demos now. How are we doing on time? 11:32. Monica, do you want to go ahead and take over and put the first demo in here? It's basically just going to be showing an example of partition pruning. And the second example is just an example of infrastructure you might use to migrate from a non-partition table to a partition table in something like a live environment where you wouldn't have any available downtime to you.
Sure. And I actually forgot to run this poll.
Awesome.
So I'm going to put that poll up if you guys don't mind answering some stuff there while I get this.
Awesome. We do. I did forget to mention, does anyone have any additional questions? I saw the Q&As, the 3 that came to me. I don't know if I answered them sufficiently enough for you, but if you want more information, I would be happy to reply to any questions either submitted to Monica or to me in email form after the fact.
All right, here goes the demo.
Okay.
All right, so in this first lab, we're just going to demonstrate partition pruning using a very simple example. I've got an employees table here with an employee ID, which is a serial or identity column, which basically is just an indication that for every insert, the employee ID will auto-populate and increment up. We're partitioning by range on employee ID. That is the virtual table that we created just there, and here are the underlying child partition tables. And I'm only going to insert about 29 records or so. You can see here a select star. This is what it's going to largely look like. So I'm going to use explain basically to show what the SQL planner is doing behind the scenes. If I do a select star against everything, of course, it's going to scan all 3 partitions. But when I start filtering or limiting on employee ID, which is of course what I'm partitioning on, it notices how to proof out partitions that wouldn't potentially have any of these employee ID values. So it only in this case scans the first partition. And this one here, you'll see it scans both the first and second partitions because those are the only partitions that would have values, less than 19. So this is an example of partition pruning. I hope it's quite obvious. If you have any questions, just hit me up after.
Are you guys able to see the screen?
Yes,
See,
we can see the screen.
okay, I see a question from Mark. Screen is not showing in Zoom. Interesting. Okay, did anybody have any questions on that demo? There's a second one, just a little bit longer, and I can provide the DDL for these. I believe Monica should be providing them after the fact. I also include them in a chat session before this started. Monica, do you want to go ahead and run the second one?
Okay, so in this second lab, we're going to demonstrate a proof of concept of infrastructure that you might need to migrate a table, large table, from a non-partition table to a partition table if you can't, take any downtime. So for this example, we'll be using the same table structure as in the previous demo. Employees, again, imp ID is serial or identity, so it will auto-populate. Imp name is just varchar 50. I'll go ahead and insert the same 29 records into that non-partition table, and then I'll create the partition table that is intended to be the target table or destination table. In this case, we're going to create 4 partitions. You'll notice we include an actual default partition to serve as a catch-all for any values that don't fall between the 1 to 30 employee ID range values, and that is because we're actually going to be reseeding the imp ID serial column for the partition table. We're going to actually, so you'll notice here the highest record is 29 at the moment, and we're going to do 29 plus 1,000 on the partition tables serial, and that is to take care of or to prevent collisions for any concurrent inserts going into partition table while we're migrating all of the rows over. Obviously we have a buffer of 1,000 here in actual production environments. You probably would have a larger buffer. So you'll notice here now the next value that would take place if a value were to be inserted in the partition table would actually be 1,030. So now I'm going to go ahead and change the name of the employees table to employees old. And when we do that, then we're going to put a view on top that unions all between the employees old and the employees part table. And that's going to take care of any concurrent read operations while we're doing the migration. Now, the issue with a union all view is that it can't accept inserts, updates, or deletes. So in order to handle those, we actually have to create a trigger and a function to attach to that view for every insert, update, or delete. So in this case, I'll go ahead and create this, and then we'll review the contents of this trigger just very quickly. It takes advantage or leverages the concept of a TG operation or TG op for any inserts, updates, and deletes, and then it uses if-then logic to to take a set of actions depending upon what action is taking place. This will be called for every row that gets inserted or it gets attempted to be inserted into the view. For insert, it's going to insert only into the partition table. For delete, it's going to delete both from the partition table and from the old non-partition table. If it's an update, it'll first check if that row exists in the old non-partition table, and then it'll scoop it up and put it in the partition table, and then it will update the records as intended, and it'll delete it essentially from the old partition table. And then, of course, if the row only exists in the partition table, it will simply update it where it's hosted. Now we'll create the trigger to attach that function to the view, and we'll go ahead and test this out just really quickly. In this case, we'll be inserting a record, an employee Boris, and we'll check real quick. Of course, I'm executing this against the view. You'll see that record exists, and you'll also notice that the employee ID is 1,030, which is a good indication of where it landed. It does not exist in the non-partition table, but does exist in the partition table. So that's working as expected. Now we'll try an update real quick. We'll try first an update for a record living in the old table. So employee ID 1 is actually James. We're going to update that employee name to Jimmy. I'll run this real quick, and I'll, of course, first here check this. You'll see that the employee ID is 1 and the name has been updated to Jimmy. Where does it live? Does it live in the non-partition table? Nope, it's actually been scooped up and put into the partition table. So that takes care of updates from the old table. Now we'll update a record in the partition table that never existed in the non-partition table. We'll change employee name Boris to Johnson, no relation to the former prime minister. You'll see here I'll do a select. Okay, that worked. And then if I, of course, check the old table, that record never existed in the old table, so you wouldn't expect to see it there. And you'll notice it does exist in the partition table. Now, we'll try delete real quick. First, we'll delete the record in the partition table. Okay, the delete took place. You'll notice when I execute this against the view, it doesn't exist in either the non-partition table or the partition table. Secondly, we'll try deleting a record that existed in the non-partition table only. We'll delete employee ID 2, Allie. When I do a select from here, you'll see that, of course, that record no longer exists. When I check the employee's old table, it also doesn't exist. All right, now we've created that. It'll take care of any current operations going on while we're migrating everything over. So this table right here is just going to serve as a watermark. While batching, it'll take the last record, insert it into the partition table, and make sure that that is where it starts when it looks back at the non-partition table for more records. Excuse me. So we're going to actually be batching these records out in ranges of 10. On an actual production environment, you would do, of course, much larger sets of batches, but you might do 1,000 or 10,000 depending on what your Postgres SQL cluster has available to it in terms of resources. We're just going to use a simple loop structure to do this. You'll notice it took only 71 seconds. There's only like 29 records in here. It would obviously be much larger in an actual live environment with larger tables. We'll just test this real quick. You'll see that all records have been moved over, and of course, nothing exists any longer on the old non-partition table because I, of course, cleaned those records up as I went. Okay, so the last thing to do is to basically drop all the infrastructure needed, to move this. We'll drop the view, drop the table. You, of course, run this as one block. I'm just showing you guys. And then, of course, rename the partition table to the name of the original table as existed. I hope you've enjoyed this demo. And if you have any questions, don't forget to hit me up shortly hereafter. Thank you.
Okay. Oh, can you hear me?
Yep.
Okay, so that's it. Does anyone have any additional questions they'd like to posit? Okay. Anyway, those are the demos and the presentation. Hope you've enjoyed our time here. Let's see. Do I have something? Yes, I'll provide the slides shortly hereafter. Would I just do that in the chat, Monica?
You can share it to me and we'll get it out to everybody.
Okay, we'll do it that way and that'll work. Okay, well, I've thoroughly enjoyed presenting to you all. I hope you have a wonderful day.
Thank you, everyone. Thank you so much, James.
Thank you.
Hey, thank you.
Guys, this Friday and for our other July and August events coming up. So see you all soon. Take care. Bye.